Hi everyone, in this video we'll be going over the second problem. So for the second problem, you're going to want to take a similar approach to the first problem. So as a reminder, it starts with reading the problem carefully. So you'll want to identify what two things you're comparing and any variables that are in the problem. So you'll see we have a lead sphere and an iron sphere. So those are the two things you're comparing, and then looking at the variables, you have the radius and you have the mass, and then also you have the density. So even though that's not in the actual part of the problem, this note at the end is a good hint that you might have to use density later. Great, so now the next step is to write down equations that you know using the variables that you underlined. So we see that we have mass and density. So similarly to the last problem, we're going to use mass is equal to density times volume. And then we're going to look, we see that we have information about the sphere and the radius. So that's a good indication we're going to be using volume. So the equation for volume of the sphere is volume equals 4/3 pi r cubed. Now we'll want to turn our equations into proportionalities. So as a reminder, you change the equal signs to proportionality signs and get rid of all the constants. So for the first equation, there are no constants, so you'll just write it as mass is proportional to density times volume. Now for the second equation, we'll have volume is proportional to the radius cubed, because 4/3 and pi are both constants. Now just like for the last problem, we can combine these two proportionality expressions because they both have volume in it. So substituting in for volume, we have mass is proportional to density times the radius cubed. Great, so now we have our proportionality expression. So again, you'll want to put one box on top and two boxes below the expression. So looking at what we're comparing again, we have the lead sphere and the iron sphere, and we're supposed to find out information about the lead sphere. So you're going to want to put the iron sphere on top and the lead sphere in the middle box. And then once again, the factor line is always going to be at the bottom. And just as a reminder, the way this works is the top box times the factor box equals the bottom box. So the iron times the factor is equal to the lead. Then the next part of setting up your equation is under the proportionality sign, in the factor box, you're going to want to write an equal sign. So then this expression has radius cubed as a factor. So again, when you see that exponent, you're going to want to write semicolon and then just the factor for the radius outside of the box. Now let's start looking for information in the problem. So we see that it says that they have the same mass. So if they have the same mass, the factor is going to be 1 for the mass, because to get from one to the other, you just multiply by 1. Then we see that it says to assume that the density of lead is twice that of iron. So again, the factor is going to be 2 under density. And then what we're looking for is radius cubed. So we're just going to mark that off with a box. So writing that out on the side, we have 1 is equal to 2 times something. So solving for that something, we get that the something is equal to 1/2. So you can go ahead and put that into the factor line. But if you look at the question again, you'll see that it's asking about the factor of the radius, not the factor of the radius cubed. So on the side, we'll write the factor of the radius cubed is 1/2. So then to get the factor of just the radius, you're going to have to cube root both sides of that. So the factor for the radius is going to be the cube root of 1/2. And there you go. That's your answer. I hope this video was helpful. Thank you for watching.